we're going to be looking at some ways in which we can record some data for models in a very easy way, and we can export that data for analysis, whether it's with SBS, SAS, R, Stata, whatever tool you want to use, okay? And to this end, I'd ask that you go to the website here under example models, and there should be a model here that is called, it's a suicide ground truth, okay? This is a model which I put into place for other purposes, but which illustrates the basic use of databases in a way that we'll then build on. Okay, so here we go. Okay, it should be called suicide ground truth. Do you see it there? No? Okay, so I don't.
For mine, it was right down the bottom.
It was down at the bottom? Oh, yes, it's a file. It's a zip file at the bottom. Thank you very much. There's a reason it's a zip file having exactly to do with the focus of this presentation, or a focus. So it's down at the bottom. You can find suicide ground truth. It's in the example models, but it's a zip file rather than a folder. Did you find that? Yeah. Okay. Now, as a zip file, I'd like you to go to the folder and then try to unzip it, okay? And it will create a folder. It should create that folder by the same name called Suicide Ground Truth, okay? And if you go in that folder, you'll find an ALP file as well as other things. I'm going to go to AnyLogic now. I'm going to close all models, and I'm going to actually go and open this model up. Okay, and this model is going to be unsurprising in most of its mechanisms, but it will show the use of a very important mechanism called the database. So when it goes to the capturing the dynamics of these models in a detailed way, one of the options that AnyLogic has recently built up for us is the ability to maintain databases within a model to which we can write information. Okay, so here we have three databases. And honestly speaking, database functionality I find a little bit flaky in AnyLogic. Flaky in the sense that sometimes I have trouble deleting the information from the database after the fact, and takes a little bit of futzing. It's come along quite a bit in the past few versions, but I'm just sort of telling you my experiences here. But if you go down to, do you see database associated with this model? Do you see that? Okay, this database is actually maintained in a separate folder within the model, okay? It says database here, yeah? And you have to realize that it used to be that the ALP folder sort of provided access to the model as a whole, but now there's some information stored in the database, okay? Just be aware of that, that database folder. And if your model uses that database, you'll want to distribute both the ALP together with the database folder. Okay, so within this model, you'll see there's this area called database. And, thanks a ton. Thanks, Jeff. And within this database, you should see three databases. Do you see that? Okay. If you double click on one of them, you should see some structure here. You will also see properties associated with it, okay? And just clicking around more, you'll see here's some information maintained in it. Okay, this is information in the database. But if we just click once on this instead of opening it, what we'll see is a definition of this database. A definition in terms of the column names, the fields that we wish to on which we wish to maintain information. Information on a given field includes the name of that field, which will be important for placing data in it and for interpreting it naturally, but also the data type of that field. What sort of information is stored there? And you'll find a bunch of different data types here. Okay. There is some further information relating to sort of relationship between fields with so-called primary key and foreign key. If this field refers to a field of another database, items in the field of another database, you can maintain that information. And this unique one will indicate, okay, is this a unique item in here, as would often be the case for a primary key, for example, and should this one be indexed for quick lookup. You'll notice this is the name of the database here, and there's some additional options here as to how to handle large numbers, how to handle large amounts of data and so on. At times I've stored hundreds of thousands of items in this database, and I would recommend considering marking it for larger amounts of data in those cases. Okay. Now you'll notice that I've created several such databases, each with a different purpose. They have to do with different concerns here. So one is kind of daily reports, one is suicide incidents associated with a particular agent, and one is sort of whole sort of epochs associated with copycat suicide. This information, the information in this database is being accumulated as the model runs, and I'd like to show you where. If you go to person here, I'll show you a few places where this is accumulated. So if you go to person, you can look at this situation here, where there's a transition back, and this is actually indicating an occurrence of a suicide, and it's sort of the individual is replaced in the population by another to keep the population constant. But the key thing to notice is this one here. There's this insert into. This inserts into a database information for these columns, and it lists the columns out. The columns you may recognize are named by specifying the name of the database dot the name of the column. And then we insert values as specified by these expressions or formulas. Okay? So, for example, for this person, we're going to insert into this component the current time, their ID, and then some indication about whether they were influenced by another suicide, news of another suicide. And then we execute this query that we execute this insert, and it places that information into this DB suicide to suicide incidents in this sort of information. That's where that information came from. Okay, and you could see that you can browse down this information. Now, having this information in the database is useful for accumulation, but as you might expect, there's also a side for exporting it. Incidentally, there's other places in the model where things are recorded. If we go to main, for example, we go down main, you notice there's a thing here for report incident daily cases. This goes into the daily reports. Similar sort of thing, insert into this for these columns this information, and then telling it to execute. There's a similar one associated with this this sort of copycat and non-copycat suicides, I believe. Here we go. Okay, so.
So Nate,
Yeah.
the syntax there.
Yeah.
Insert into.
Yeah.
That database.
The name of the database.
And then you specify there's 3 columns.
The columns,
there.
and you notice that each of them is logically a column within that database.
Yep.
So the database name that was given here, that's used as the kind of qualifier for the column. So
prefix.
yeah, that's right.
Yeah.
So it's this column within that database. That's going to be the first data item because it's the first in this list.
Yep.
And so that's going to correspond to, so this insert into this field is going to be correspond to over here
Where the values are listed.
the time. This is some variable, time started.
Okay.
The next one is going to be a stop time, and that's actually going to be the current time. Okay. So those are the 2 values being inserted into this, into those corresponding, those respective fields.
Columns.
Yeah, or columns or fields. And then you have to say at the end of this, dot execute. These are the values in which to insert. So you specify the database, specify which fields do you want to insert into successively, the values successively for those respective fields, and then you do dot execute, and it will actually perform the insertion right into that database. Okay?
So that's how you kind of collect individual.
That's one very powerful way of doing
Yeah.
it. That's right. Now,
So there's another.
it's not the there's certainly other ways. This
We
is
were doing it similarly within.
That's statistic. Which
What was
is,
it?
yeah, insert data set.
Yeah, data set.
you can put into data set, and we'll see how to export those in a few minutes.
okay.
Okay. Yeah. So databases are kind of a first reference when accumulating this information for a reason I'll be talking about. They're a comparatively new feature. For years, I've taught students how to export data sets and how to export text files, data sets to text files or to Excel files, even to write to cells in Excel files live. But the advent of databases in AnyLogic, while cumbersome in some respects, and while I think it still needs some refinement, it's reached the point where I'd say this would be, for many models, my go-to way of recording this information. And I'll show you the other part of that equation, the other side to that equation, which is once these are accumulated, you can then export them really easily. We'll come to, you can also import them. You can back them up, you can restore them, you can delete them, but you can further export them. So you could say, okay, I want to export, this data set. No, the mechanism for this is frankly fairly, I find it fairly cumbersome. So I say, okay, export settings, which tables do I want to export? Okay, I want to export that table. And now I'll say, okay, now export them to Excel. Boom. Okay, it'll go export, and this is where to whence I want to. No, this is whither they go. This is whither they go. So I'm putting them in an Excel file, and if memory serves me, that Excel file has to exist right now. So if I were to say, foobar I don't exist or something like that, to give it a file name that doesn't exist, and I were to say, okay, here's my thing, and I were to say export, oh, okay, it's happy, okay, now there's a file of foobar I don't exist, okay, which gives a certain lack of clarity with respect to what's going on. So this is in where is this? Oh, I see. This is in my home folder. Okay, fine. So here we go. Let's just go and see if it's there. So here we go. I'll sort it by date. Here we go, and there we go. Come on. So no, it does not look like. I think it. Sorry. It could be, but I don't think so. Give me a second. See, this is what I mean. Come on, tell me. Oh, it's in recently used. That's not very helpful. Okay, fine. I'll go put it in my temp folder. Here we go. Put it in the junk folder. Here we go. Okay, export. There we are. And let's go see if it's in TMP. Okay. Okay, fine. There it is. Boom. Okay. Yeah, there it is. Foobar, I don't exist. Okay. Okay. So I was wrong. It looks like it doesn't require it to be created up front, which was a cumbersome thing about AnyLogic's other exporting mechanisms. Okay, so that's nice. You'll notice you can also set it to export tables at the end of each model execution. So every time you run the model, it's exported with those settings. And you can import tables from data sources. Okay, I can bring in data from a different data source and make use of it. So here, I could say I want to import it from an Excel file or from an SQL server, and I want to import such and such tables. That's kind of a useful thing. One of the more interesting uses of this, though, is something that we did a number of years ago when AnyLogic expressed some interest in it, and we encouraged them to allow it, and they actually did implement this. I credit Jeff and my sort of persistence as this is one of the features that AnyLogic included. So here we're basically logging model execution, okay? And what this allows us to do is to log basically events within the model, okay? So we can log when messages are sent, for example, within the model, or when a person transitions between projects. And you notice it says log will appear in the projects view after you run and close the model, okay? And so I'm going to run this model here. I'll run a baseline case, sure. And as it's running, there's some information being accumulated. Here we go. I'm going to stop this, and I'm going to leave this. And here's a log. And you notice what this log includes. It includes information about many different types of information going on while the model is running. And this is all because I said log model execution. So let's take just a little bit of a look at it. Here's for example, agents log. So these are the agents, when they got created, what was their birth date, or the date at which they disappeared from the model here, right? Here we'll have a flow of, these are events that, I believe, yes, this is events that were going off. This was a daily event which went off. We use events to indicate things that fire at a regular rate, and Remember, we did that for the immigration, and we had it going off at a rate, or we can do it at a fixed timeout, so it's a cyclic thing. Very commonly used for reporting. We have it go off daily, for example, and that's what this event is doing. To be clear about where that occurred, this is up in Maine. Report daily incident cases. I showed this to you earlier, but I didn't emphasize this is cyclic. At first time it goes off is time 0, and then every 1 day. And so this event was its occurrences were being recorded here. And note that I could say I don't need this type of log, and it can help clean this up. I could further record information, for example, about messages. These would be messages sent by one agent to another agent, for example. Just like we have the clinic send a message to a person saying that you are now motivated, or we attempt to motivate you, get motivated, and the person could ignore it or not, depending on their characteristics. This is where the events can be recorded, right? And as you can appreciate, there's quite a bit of information. It shows the timing. So a record like this can help in debugging what's going on. Are messages even sent? Are new agents being created, etc.? It does provide a way of getting some understanding of what's happening, and by extension, what's not happening within the model. Similarly, state chart transitions, right? Here, they went from one state chart or they were within a given state chart. There's a transition that they followed from a certain state, and they went along this transition, and it identifies who it was that was subject to this and at what time, right? So this is useful. I think this trace log may be, yes, I think this may be when you do trace LN, but I'd have to double check on that. And then there's some sort of data behind this. So this sort of information can be part of your databases and can be used to go and sort of record what's going on here within the model. Now, I had thought there was here a way of easily exporting. Yeah, I think this is all part of this. So we can do export settings, and then you could say, okay, I want to export the messages log, for example. And here I'll say, instead of foobar, the unlikely name, I don't exist, I'll say example, okay, no, you can't edit it. You have to go, fine. We'll put it in temp, good, and we'll say example message export. Okay, here we go, and we will say okay, and then we actually have to export it, and now we have an export of this data. Okay. Useful for debugging, useful for documenting what's going on, but it is voluminous. It is voluminous. You can also clean up the log here by deleting it if you don't want to keep it around. Okay. Do be aware that in general, storing away data like this can have some performance implication. So, it may slow your model down some to have this data. On the other hand, it may mean not having to rerun your model if it records incidents of interest to you. Okay? Some features of any logic databases. You can import them from places. You can define custom structure. You can place data into that structure. You can export them, and you can readily accumulate events from the model to within this database. Okay?
Can you import data from outside and then use that data to feed
Can.
the model?
Can. So let me go show you something. So if you go to main in this model, you notice that, remember when we talked about setting a population by population size in our model? Here, we could say model's initially empty, contains a given number of agents, or we can actually say it's loaded from a database. And here, we could say, well, from what database do we wish it to be loaded, okay? And do we wish to have one agent per database record or multiple agents per record, having some specification for each record how many agents there should be in that record, okay? So the idea is you could have agents with a certain type and then specify 3 of this type, 2 with that characteristic, or you could just have their characteristics and you just say import it into the agents.
So the records, they have to be individual agents per row.
Well, no, because this multiple agents per record is designed to allow you to say, like, maybe you want to say, male children 0 to 4 years old, there's 223 of them. Maybe male children 5 to 9 years old, there's 122. That's what this multiple agents per record is designed. You could specify like whole demographic categories, how many of that demographic category, and it would create that many agents of that demographic category. So it doesn't have to be individual agent in each row. It could be, but you have the option of having multiple agents with shared features there, okay? Multiple, like shared ethnic, sex, age, characteristics created at once, right? So you might have a stratified enumeration of your population. Let's say in this population subcategory there's so many, this one there's so many, and it gets created with exactly this, multiple agents per record. That's why you basically say, where's the quantity of agents to be created of that type? So you might have, male, so sex, fields might be sex, age group, number. And you'd import it accordingly. So the number would be the quantity. And these would basically use the male and age category to initialize the agent. Huh?
Okay, I will try. I don't know yet.
Here, you want to do it? I mean, are people interested? We could do it. What do you think? Okay, there seems to be lukewarm support, so maybe we won't do it.
Just my question, I would just go and test it.
Yeah, I mean, basically you have, you would need to have an external thing which says, sex and age category and count. Then you point it to that, and you would need your agents in your model to have sex and age category, and when you create them, it'll create that many of that appropriate sex and age category. Yeah. Anyway, so yes, it can interact with your model in some significant ways.
No,
Yes.
just through the last couple of days, you've occasionally said to Winchell, this is a pattern. Can you just note this down?
Yeah.
When you say a pattern, do you mean that this is something that you would commonly need to do within any logic? And
Okay, so
are you planning to put together some sort of a reference with, to create a database? Here are the 7 steps that you typically need to do.
yeah, so
So that when we come back to this, we can remember. I know that you can do this thing in any logic,
Right.
but I can't remember.
yeah, so the issue.
Last year we asked the same question.
But so it's the how-to guide for those who can't remember
Yeah.
all
So,
the details.
so the issue here, in my view, and this is something I've discussed with Jeff, as normal with his, sort of profound perspective on these things. We've talked about these things because, look, the part of I love teaching these events. But part of what makes teaching this effectively challenging is that there is a mismatch between the level of description of the pieces of the model that you add in at a time. You add in a parameter, for example, at a time. You add in an event. You add in a variable. You add in one state at a time, or an entry to state. But, man, if Winchell were here, I'd ask him to take this down. You add these things in at a time, but the natural unit of organization of your model is at a higher level than that. It would be as if, I like a good analogy. Imagine, you had to specify building up a person cell by cell and so on. I mean, yes, there's things that are cell by cell, but there's whole organ systems and organs and sort of structural units that are not determined on a cell-by-cell basis. They're higher-level aspects of organization that go together. And when we build up these models, much of which what I'm teaching you is actually, I'm teaching you common ways of doing something, common ways of achieving this functionality, common ways of, achieving two state charts that interact, for example. So you can have two conditions, heart disease and smoking, and they interact in some way, right? Or having a way of having agents come into the model over time. And to characterize that, it's more than add an event. Yes, an event is part of the solution, but that's just one piece of a whole. You're adding an event, you're going and you have an add underbar, whatever to call to add them to the population. And you are specifying the values of parameters. But more than that, you are going probably to location properties so that when agents come in, they're added at the right locations visually, within here. And you also are probably adding something to this is an immigration related thing, you're adding something to their state charts to indicate which initial state they have. Those kind of go together. Yeah. And the problem with any logic's kind of mode of description right now is it's reduced to these pieces, right? Mm-hmm. And so, you go back to your offices and you stare at these pieces and you say, like, which piece do I need? But really that's not the natural unit with which to describe a model. It's basically, in system dynamics, the term for this sometimes is molecules. There's kind of repeatable units of organization out of which we build a model that are a much higher level than this might suggest. And when we build a model, I'm thinking in terms of these chunks. Okay, we need a chunk like this, we need a chunk. When Winchell's thinking about a model, he's thinking about chunks. Okay, these things kind of go together. And I'm thinking about a state chart. And this state chart is going to interact like this. Or I'm thinking about, okay, we need interactions between these state charts. We need a variable by which to communicate it. And when you switch one, you have to write to that variable, and the other one needs to use that variable and its hazard rate or something. Those kind of go together. And instead, we're reduced, it's like looking at the world through a straw. It's horrible. It's horrible. Yeah.
And also, it's quite difficult because, I actually think a little bit like that, it's fine. Because it allows you to customize to what you need. But I think the difficulty is when you're going to use function, when you're going to use variable.
Yeah,
exactly. All of those.
Exactly.
I read help, but it doesn't help.
No, that's right. It's this higher level sort of decision of like what you need to do and how that's connected with sort of chunks of requirements that are needed to deal with that, to capture that need. Yeah, and then so that's kind of the tactical level, and then there's the strategic level, which is even harder, which is getting students so I mean, there's one thing to build the model right, which is a lot of what we've been talking about, but then there's building the right model. What should be in there, what should not be? What's the scope of that model, given your research interests and questions or the problems that you're trying to address? What's kind of the natural sort of what's the natural scope or boundary of the model? That's even a higher level question, and students find it much more difficult to deal with that even than these blocks of organization. So here when I was talking to Winchell, I'm talking about capturing these patterns, these molecules, whatever you want to use to describe, these things that go together, these higher level abstractions that get added. And I have a lot of thinking about what those could be, and I think those could be described. I also think that health sciences will be well served if those natural units for organization were available as building blocks. So you don't add, not everything has to be articulated at a kind of micro level and woven together manually by you folks to make this unit of organization. You can just plop it in.
Yeah, like with a state chart, the default might be
That's right.
The starting point and say 3 states.
That's right.
Arrows connecting.
That's
and then
right.
maybe if you needed to, you could delete bits or add bits in.
That's right. And so Jeff and I have made proposals along these lines, and it will require a substantial reworking of this interface to capture it. I actually think that the building blocks used in health are going to be different than the building blocks if you're describing a factory. And so it's a somewhat domain-centric thing. Winchell has actually done quite a lot of work building custom palettes.
Okay.
Where he has higher level units to drag in for particular purposes. But there's real restrictions what we can do in any logic of that sort. I mean, you can do it for certain things, but not others. And I feel, I feel that there's a need to get to people who come through the boot camps these higher level molecules or higher level patterns that we use, so that we can teach people, oh, this is just a variant of that pattern. You need to do this, you need that pattern. And maybe their job is reduced in complexity by half or a quarter because they can reuse these patterns. They can just put together these puzzle pieces, and then there's going to be some custom stuff in addition to that. Anyway,
in the meantime, you find an example, it's a bit like what you want, you torture it into shape.
Change the names.
yeah, and part of the problem here that makes this so vexing is that, so I've given you all these dozens of models, and a foremost weakness here, and I implicate myself in this, because I too have feet of clay in this regard, is I give you these models and they've been built up by patterns. I'm thinking about how am I going to do this, and these things kind of go together. I'll finish a logical chunk of work and save it. Finish a logical chunk of work, and I'm adding these things in with these patterns in mind. But the problem is once you add them, you can't see them anymore. So I mean, it bites both ways, right? In order to think about a pattern, I have to build it up piece by piece. It's like death by 1,000 cuts. And then once I give a model to someone, they don't see the patterns out of which it's built. And so they don't understand what are the kind of logical chunks of organization of this.
Versions of the example,
Well, that's true. You could sort of say what got added here. Oh, it's a chunk of like that. That's true. That's a very good point. But it's cumbersome to look at that in today's software. So, to be able to compare these side by side, you can't even have them open at the same time because of what Amir and I talked about. The naming, and the point is that when you look at those models, you don't see the thought that went into kind of adding this chunk and that chunk. Oh, that's just this working with this. What you see is a cacophony of minutiae staring at you. You know, it's just this kind of bunch of things that without obvious meaning and how they fit together.
I think that when you're teaching it, if you repeat, say, the process of
Yeah.
doing
Yeah.
a state chart, so
Yeah.
you talk about that, and we do 3 or 4 of them, even though it might seem tedious
Yeah.
to you, I think for me, sort of
Oh.
starting from 0,
Yeah.
when you repeat it, you get the mechanics down, you get the molecular
Right.
down, and then you start to see
The pattern.
the
yeah.
bigger pattern. Once
Yeah.
you're up to the 3rd or 4th one,
Yeah.
that would be my sort of ground level looking up view of learning this.
I agree, and
stuff.
that's why I repeat these
Yeah.
things. And in different boot camps, you know, quite a few boot camps. I mean, this boot camp has been extraordinary at several levels. But one of the ways is not only the sophistication of what we've done, but something that went along with that is that we, you know, most of my boot camps I built up from scratch, maybe 8 different models, 10 different models, you know, each starting from scratch and going in a different direction. Here we've had one model and it's sort of followed this thread, and it's been like Jack and the Beanstalk, and we end up in the clouds. In a pretty view it is, but you know, there you're not rehearsing some of the basics again and again and again. And but you are adding in state charts, you know, sort of successively. And so, yeah, I mean, you know, you probably there should be an effort to lock me down and have me produce as a series of lectures, you know, this pattern, that pattern, that pattern. This is how we use it at a more sort of high level, and then I can name that pattern and say this is just an instance of that pattern. I'm adding in a first order delay here. I'm adding in a, you know, coupled state chart pattern. I'm adding in a pattern for performing this sort of statistics-based calculation associated with you know, graphing or what have you, because, you know, I need to do a graph of this, and so I need a statistic that will compute the graph, and then I need to do a graph of that statistic, and you know, that's a pattern that goes together. You sort of, the graph drives the statistic, and probably I could do that. I need the cage to lock me down.
Lock the doors.
Yeah, exactly.
That's how
I have some comments about like, so we were talking about earlier having like the building blocks or having like a house library or things that's
Yeah.
like not the atom level, you know, like these hiding blocks. So, I mean, I feel like in discrete event modeling or process modeling, those blocks are more developed. You will see, like for factory, you guys see like
Yep.
conveyor object, you see
Yeah.
like
Yeah.
rack system object.
That's right.
And I guess this is 2 sides of things. When you have those building blocks pre-made for you, you can be like, okay, well, I can just use that. I don't need to waste all this time putting together all these atom cells, molecules,
That's right.
body parts, and build everything from scratch, which is great, which is good. But the downside is, if there's a block that says hospital or clinic there, do you, like, as a novice user, it's very hard for you to figure out, okay, is this clinic kind of like the one I work in that has like 3 doctors and, you know, 1 receptionist? Or is this clinic have like, you know, 50 different doctors? And like, so it's really hard for you to know what they mentioned, how this block was constructed, how their patterns, how their structures made initially in there, and what sort of parameter or variable you can vary, like how it works logically inside. And so that's the trade-off. You save some, and then there's, depending on how much you know, how much you are able to adapt and what the situation it is, and how well the box is designed. Sometimes you'll run into situations that the unintended You say, oh, I have 3 clinic, I just use 3 clinic blocks. Oh, well, not really. These ones really work really different than what you think it works. And then, so there's all these different things. And then I think for building factories or discrete events, I mean, I see this all the time. Like people who are into modeling first project and they see, oh, I can use this block, this is great. But then they come out with resorts that's like, it doesn't make sense. I did everything right. Well, it didn't make sense because you interpreted what they intended for this to do. And I guess perhaps for physical systems, like conveyors, like rack systems, I mean, in material handling, there's kind of it's more the same, I guess. They're more similar, so it's easier for these blocks to be created, and there's a consensus on how they are. And personally, I feel like house or human behavior psychology, these things are just so even more varied than like a mechanical system, mechanical boxes and whatnot. So perhaps part of the benefit of not having these blocks is for you to really think, to really construct that yourself, or the value of thinking through these interaction behavior processes and whatever. That's my feeling.
I think those are worthy comments, and they relate to the fact that, a couple things. First of all, this issue of pattern languages of design using patterns, it's actually a very well-trodden area. I think at first a lot of the discussion originated in architecture and kind of some degree maybe urban planning type issues, but particularly architecture. And then it made its way over into another area where I work, which is software engineering, and we talk about software patterns. And there's a huge amount of literature on software patterns, which is, some of it's been more useful than others, I'll certainly say that. It had some worthwhile things, but I think a lot of it is kind of becomes, stamp collection and stuff. It's kind of not that useful functionally, but just kind of curiosity. But Jeff and I have sat down and systematically tried to think through this issue when we grapple with what Annie was talking about, that in health there's actually a lot more variability than in supply chain management or aspects of certain types of logistics or what have you. I mean, it's just, health is just very different health areas. There's very, very different concerns and so on. And the building blocks of health, I think Jeff and I actually have a very good thought about what those would be. It's just that it requires a radical sort of reshaping of how you describe models. And that's a bit of a leap of faith for anyone to try to undertake. But I think there are natural building blocks. But I still think we could do a better job of saying, in terms of these components, what are the, even if we don't have a software package that allows us to drag in a causal pathway, a risk factor, drag in, what's that? A chronic disease, drag in care-seeking behavior or something like that as a natural unit of organization. Even if we don't do that, we could at least do a better job of sort of articulating what are these kind of natural chunks out of which I make it. And I could certainly do a better job in the models I give to you of sort of articulating what the dividing line is between those chunks, where those are divided up. So this is, I think, worthwhile comments, and I welcome the feedback. Jeff, any more you'd like to say about this?
I think it's a big task, and I think we need to get a sort of critical mass of a body of people, and we look at the differences amongst the models and then generalise to patterns. I think we need to do a lot more work at a particular level. I think we tried to do it a bit early, but we felt there wasn't enough experience. One of my sayings is that models are like children; they're not very attractive unless they're your own. So someone else's Someone else's chunk may just not be very attractive. Sorry about that. Could I leave that? Open the doors.
Yeah. Good. Okay. So, any logic databases?
Pat?
Good stuff. Yeah. So, any logic databases are a very useful mechanism for recording information, and I think I'm just watching the time here.